Hey there, welcome back to another exciting video on our channel. Today we are diving into the fundamental building blocks of programming, that is data structure and algorithms. So the top title for today is data structures and algorithm. Now, data structure and algorithm are the backbone of computer science and software programming if you talk in broad. And if you think of data structure, so like think of data structure as the different ways we organize and store data. So how we different ways we organize and store data, and algorithm as a step by step procedures we use to manipulate the data. So that's where we study data structure and algorithms together. So with whatever the data we are organizing and storing to suit the algorithm which we want to apply on that, it can be thought in that way as well. But before we move much, I'll give you more detail about the data structure and algorithms in the upcoming video. I just took some few examples which I think the data structures exist and algorithm exist in real life. So this is a to-do list which basically it's like a list we want the task you want to do, right? So let's say if it is 0, 1, 2, 3, 4, 5. So there are like six tasks. Let's say it's a task 1. Similarly, 2, 3, 4, 5, 6. So now these are the different 6 tasks we have. Now each task in the list, if you see, has a specific location or specific position. So if I say what is my task number, let's say 3, so this is the one. So don't get confused with this. This is for a reason. I am writing this because this is nothing but this is an array. And in Python programming specifically and other programming, the index or the first element of the array starts at 0. That's why I'm assigning task 1 as a 0. Because since we are studying data structure, so let's study correctly from the beginning. So that's what. So every so this array, this to-do list array is basically holding a collection of elements. And what are the elements? So this is called elements. So 6 tasks or elements. Okay, so 6 tasks or elements. So every element has a fixed position in this list, and we can access directly the task by referring to its position in the list. For example, if I say what is the task number 4, so I can directly go to this location, which is the index number 3, and that will give me the task 4 directly. So this list and all we'll study about arrays in detail, but that is one data structure which we see every day in day out, right? Now moving on to the another type of structure, So let's say, suppose you are in a party or somewhere, and there is a, this is like a stack of plates, right? So when you start going for the food or something, you start picking up from the top, right? But when somebody is putting, so let's say somebody is, let's say this was in an enclosed sort of container, so somebody kept it inside. So this plate was the first one to go inside, and that is the last one to go inside in this container. But when somebody will start picking it up, it will pick from top. So this is basically a data structure called stack. So this is a data structure called stack, and that stack generally has a LIFO operation, last in first out. So whatever goes last will come first. So here again, some picture I took from Google. So you see this is an empty stack. The number 1 goes in, number 2 goes in, number 3 goes in. So this is like a push operation we have and a pop operation. But when you pop it, the third will go first, which has gone the last, right? So that's how that's again, uh, another data structure which exists. Moving on to the another example. In this example, we'll see. Now I think everybody has experienced, standing in a queue. So this is like waiting in line. So what is happening here is people are waiting in the line, which is also called as queue. And how the queue works, this person who's standing here cannot go directly to this place. This person first will be served, he will be served. Then once this person is done, the next in the queue will be served, and then the next in the queue will be served, and this process will goes on and on until unless you hit all the people in the queue are served. So this is how it will goes. Okay. So this is how. So like that, and this is how. So this is again the same concept we have taken in a queue data structure. Queue, which is another data structure, and this is from the real life. You see, this is how it is defined. Now this was more of a linear sort of things where things are happening in a linear fashion. We're accessing in a linear fashion. So now let's take some another example. So this is basically an organizational org chart. So if you are working in a company, multinational, so there's something called org chart, where generally on the top we have the CEO, and then the vice presidents or directors and stuff like that till your hierarchy. This is how it is. So basically you see this is like a tree kind of a structure, right? So this is like a tree where you have branches and stuff like that, right? So this is again a data structure called tree, binary trees and stuff like that. So again, this is a folder structure. Okay, this is a folder structure. Now if you watch closely in this folder structure, is hierarchy hierarchical structure. Now each folder, basically a node, contains files and subfiles. So here, like this remodel has this file, this, and this has another subfiles. Now creating a branching structure which resembles a tree. So this is again another example of tree. Now moving on to the another example which we have is a social networking. Everybody is on the social networking, and here think a graph as a social network. So this is a graph. Okay, so now each person is a node. So this is a node. Basically this is called a node, and this branch or this edge of this connection of their connections is called their friendship. So edge is representing their friendships. Okay, now this analogy help us to understand how graphs model complex relationship between entities. So again, this is another type of data structure what we have to which exists in real life. So now to summarize, we studied about the data structure. It's a it's a special format for organizing and storing data. So let's say data structure. Okay, so by this time you might have understood already there are two type of data structure. One is a linear and a non-linear type of data structure. Okay, now what is a linear data structure? The linear data structures are the type of data structures where elements are accessed in a sequential order, but it's not compulsory to store all the elements sequentially. Okay, like array is an example, stacks, queues. Okay, so these are the another examples of a linear type. And a nonlinear data structures are the type of data structure where elements of these data structures are stored and accessed in a non-linear order. So there is no set sequential way of accessing. You can anytime you can access to any person's details. So there is no like you have to start from here then traverse and stuff like that. So that is a non-linear type of structure. So obviously trees and graphs are the type of non-linear data structure. I hope you're getting this. Then now let's talk about the algorithm. So let's say first I have a problem which is like I want to bake a cake, and I don't know, so I just googled the recipe. Let's say I want some carrot cake. So let's find out, or let's say lemon. This is like a good number of viewers, so I just lemon drizzle cake, and then I looked for the recipe. It looks like 15 minutes good time. Okay, 1 hour should be good. Now then I focused on, then I arranged the ingredients, then I started to cook the or bake the cake. Now you see there is a method which is basically I need to follow to bake a cake. So first I need to heat the oven, then I need to beat together butter and caster sugar and stuff like that. So you see there are like proper steps which is defined to solve the problem. And what is the problem? So I was given a problem, and the problem was bake a cake. So I figured out the recipe, and recipe has steps. So in this case, like I have 8 steps. So what will happen after each step? I will have a cake. So this is basically the algorithm. So the definition for algorithm is the step-by-step instruction to solve a given problem. Okay. Now, if you see this all doing some manipulation of this data and arranging in this queue, and how to handle multiple people, how to use the stack and arrays. So basically these all are like, they are applicable for different use cases, and based on the use cases we select the algorithm and the data structure. So that's where understanding data structure and algorithms is crucial for many reasons. First of all, if you are going for company interviews, then definitely companies want you to know that. So they want to know that you can solve complex problems logically and efficiently, and also it 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 basically has a direct impact on the performance of the software. So if you choose the right set of data structure and algorithm, your code will run smoothly. And if you are not selecting the right data set, data structure and algorithm, then it might run sluggish. There will be some sluggishness in the software. And obviously learning this data structure and algorithms will lay the foundation for like more advanced topics like machine learning, AI, or some game development, right? So these are very important for for us to learn when we are doing some programming and stuff like that, right? Now there is another thing which we'll discuss in detail, but I want to point out here is efficiency of the algorithm is very much important, because this particular, so let's talk about efficiency of the, this efficiency is very important. Efficiency matters because if because it impacts two things. What it impacts: how fast our program will run, and another is how much resources it uses. Now these are very important, guys, because this leads us to two things. So if I say this is a time and this is a space, so every program has something called time and space complexity, which we will learn how we compute. Okay, don't worry about that. But that's where the efficiency of the algorithm matters, and of basically algorithm the matters. And algorithm is basically also have impact, data structure is also having a impact on the algorithm. Suppose you are choosing some data structure and a different and algorithm which is not compatible, or which has to do extra thing or stuff like that to so that's where, so selecting this right and this right will leads to this, which is nothing but the efficiency. And that matters because it will define how much time it will take and space it will use, and if it is less is better. Less is so less is better. Okay, so less time, less space is always something which we look for. Okay, so there you have it, a brief overview of data structure and algorithm. Okay, so if you really find this video helpful, please subscribe to our channel, and so that you will not miss, and you can hit the notification bell so that you can never miss an update. And happy coding, and I'll see you in the next one.